Hey everybody. I've been talking about putting this video together for a little while and finally got some time. So, what this is about is I've been seeing a lot of people talking about using or trying to use large language models for code generation, for building like red team tools, and a lot of discussion around um, issues with content policy restrictions and um, refusals by the large language models to generate, code for these sorts of applications. And so I wanted to just show how I'm using large language models for that purpose and try to kind of help people out. I think a lot of people are using like ChatGPT or some sort of, using a large language model through like a web application front end instead of using like an IDE extension or a writing your own harness for using the large language model APIs, which I probably won't get into on this video. I'm actually going to focus on using a code or IDE extension, and then I'll probably do a separate video showing how you can build your own harness or integrate into an application, making your own API calls to large language models. But that'll probably be a separate video. So this one I'm going to focus on using IDE extensions. Specifically today, I'm going to be using Cursor. So, and I'll walk through, from scratch, building out a tool so you can kind of see what my workflow looks like using this tech. So I'm just going to share my screen here. Okay. So first of all, I'll talk about what we're going to be building. So I selected for this exercise a process injection technique. And this is from Bobby Cook. And this one, I'm going to use this one because it's really nice and simple. It's originally taken from Sector 7 training, which I also did. But it's really quite simple. That's why I chose it for this video and this exercise. It shouldn't present a whole lot of issues, that I'll have to troubleshoot. I'll probably have to do some, but anyway. So if we pull up this repo Hollow and we take a look at the source code here, it's in C. It's meant to be a BOF object file, and right away we can see all the different API calls that we're going to need here, where the symbols are defined. So it's pretty simple, pretty straightforward. Create process A, virtual alloc X, write process memory, queue user APC, resume thread, and we'll need something equivalent to memset. And this is a process injection that launches a process in a suspended state and then allocates some memory in the process, writes to it, queues an APC on the shellcode address after we've, written our shellcode to it, and then resumes a thread to trigger that APC and trigger our shellcode. Okay. So pretty straightforward. Now, you could do a lot more with this and add a lot more like OPSEC, and different tricks and stuff to make this less detectable, more evasive. But for our purposes today, I'm just going to do like a POC of it. And then, later on, which is what I normally do, I will come back to this and make an OPSEC branch with some additional evasion techniques and stuff like that. But I just want to do a POC. Now, I'm going to I'm going to write it in Rust because I like to work in Rust a lot, and it's already in C, so it wouldn't be um, very fun to just rewrite it in C. So we're going to do it in Rust. And another advantage of doing it this way is that we're going to make it as a crate, Rust crate, so that we can then just easily call it from other Rust programs. So you could have like a Rust based C2 agent that you could then import this library that we're going to create and perform this uh, process injection with just a single call to a single function in our library. So I've already started to set that up. And you can see here what I've got so far. I didn't do much so far. So I just, set up a basic structure for Rust. So we have our main RS here, which so far doesn't really contain anything. It just has our shell code, which pops calc, which I took from one of my other process injections here, RPI. So I'm just copying this. I know it's good. And then it is right now just calling a wrapper function that I've placed in lib, which you can see here is just calling inject, which right now is just running hello world. And that's just our basic setup. So, main, the reason is because when we make this into a crate, these functions, well, the public function will be available to be called from another program. So in the end, just like here in main, we're just calling wrapper, you'll be able to import this crate into another Rust program and just call wrapper and execute all the functionality. The reason that I called it wrapper and the reason it's set up like this is because these functions in lib, in order to be called from main or from another program, have to be public, which also exposes them some more. They're exported functions. So a little trick here is I make a public function to expose that calls my private function. All right. So I'm not going to get into this too much, but you should get the idea. And if we take a look at it as it is right now, if I just do cargo run release, it should just print hello world for us. It does. So we know that our structure is sound, and we can start building out the actual functionality here in our inject function. So since we're doing this in Rust, one of the first things that we're going to want to do is we've identified what API calls we need. I have gone ahead and looked these up for Rust. So I know that they are going to be available in the Win API crate. And like I said, if you were trying to produce a more OPSEC safe version, you would probably use a different method of calling these APIs so that they're not exposed in your binary in strings and stuff. But for our purposes, we just want to do a POC. So we're going to go ahead and use the Win API crate for these instead of doing like dynamic resolution of the APIs. So if we come to the Win API crate, we can start to look up the APIs that we need. So you can see here, I just search for resume thread. I find the function, and I can see that within this crate, it's in the process threads API feature. And in Rust, we have to enable that feature in our cargo file. I hope this is, I'm going to try to zoom in a little bit here so it's easier to see. Why is it not? There we go. That should be a little bit easier to see. Yeah. So I've already enabled the features that I need. I know I need the process threads API and then the memory API for like write process memory. So if we look that one up, we know we're going to need that one, and we can see that it's in the memory API. It's locked behind that feature. So I've already enabled that in my cargo file. So we have our cargo file set up with what we need. And we can start to import these functions. So I'm just going to go ahead and start grabbing these functions. So there's that one. And you can see it's already looking to populate some stuff for us. This is Cursor. This is using Claude Sonnet 3.5 and memory completion. We'll get into that stuff more, but I'm just going to go ahead and manually add all of my needed functions here. So we know we need create process A. Okay, we'll grab that. What was that? Let's see. So we got that. We need virtual alloc X. So we'll get that one. And what else? Okay, Q user APC and resume thread. And we could probably just say import resume thread, and it might find it for us. Use one API. Okay, it gave us a bunch of stuff we didn't want. All right, that's fine. So there we go. Those should all be correct. So now we've got our functions that we want to use. Okay. And if we look at this, we want to start by creating a host process in a suspended state. Okay. And we could look at some other examples that I have where I've already done this in Rust, but we're going to try to like wing it and do this on the fly, and I'll pull examples as needed. But let's see what we can do so far if we try to use the large language model to help us out here. So one of the things that you can do, so there's different ways to do this. You can do Control K, and you can say, use create process A to start a new process in a suspended state. Okay, you can say that. And then it's going to, try to generate the code for us that we need. I might have to turn on fast requests for this video, honestly. But let's just see what it does here. Okay, so like this looks like it's going to be pretty close. I didn't tell it what process, so it just went with Notepad. That's probably fine. We see create suspended here. That's cool. A lot of this stuff is like nulled out. So let's look back at Hollow and see if this makes sense. So we have first argument is nulled out. And like, if we're not sure how this function works, we can look this up in Microsoft Docs, which I usually go to Bing to look up Microsoft Docs because it's Microsoft. So if we go look at the function, we can kind of see what it's expecting, right? Right. So it looks like here the first argument is actually the application name. So that's a little different here. Not sure why, but anyway, it doesn't matter. Then we have PE name, more stuff zeroed out, create suspended, zeroed out, and then our info and our P info, which are here, they're also just like zeroed out. So if we look back at what we have, okay, bunch of stuff nulled out, zeroed out, create suspended, nulled out, and then we have our startup info and process information, which are zeroed up here. So this looks like really close. We can also check it compared to the Rust implementation. right? And make sure that it makes sense. Application name is the first argument, right? We have down here, we have start info, process information, cool. I think the creation flag is probably where it says create suspended, right? So this looks pretty good. So let's go ahead and accept this. And then we'll figure out what this error is. Call to unsafe function. So we're in Rust. And when you want to do certain things, you have to wrap it in unsafe. I'm not going to get in that too much. We're just going to do it. Add unsafe block. Add unsafe block. Okay. And then this. Okay. So the create suspended flag here is locked behind the WinBase feature. So I'm just going to add that to our cargo as well. Save that, and that should clear up that for us. Okay. And then it also included a check here for failure. But we want to know also if it was successful. So what we're going to do is and you see it's already suggesting, I'll try to zoom in some more. It's already suggesting the next code, right? The large language model already has an idea of like what we want to do, and it's already making additional suggestions, as you can see here. So that's great. I want to grab the process handle and verify, that everything is good here. So I'm going to accept that. I don't really want to do this part yet, so I'm just going to delete that. And then I'm going to, another thing. So we did this with Control K, which is not what I usually use, but it worked in this case, right? Another way that you can get the large language model to generate code for you with a lot of context is to use comments. So you can start a new comment and say, print the process handle, and it will generate that code for you. And I don't know if this is going to be the format that we want, but let's just see what that looks like first, okay? So let's go run this again, see what we get. Okay, so it looks like we did successfully create our process in a suspended state, and we got a process handle for it. Okay, now it probably got cleaned up when our program exited. I don't think that that it left it, running suspended, but it did. Okay, so that's fun. All right, so we don't want a bunch of these. So I'm going to add something probably to clean this process up while we're building this, so I don't end up with like 100 notepads. But for now, I could probably just end task on that. Or actually, I don't want to make it overly complicated. Let's just keep working through the logic here. So, but you could, I think just close that handle probably and clean that up. But I'm not going to worry about that for right now. But you see how quickly, I looked at this example code and said, okay, these are the calls I need, and had the large language model generate the first step for me to create process in a suspended state, and it was successful. All right. So next step is we want to allocate memory in the spawn process. It says here we can write to the page execute read memory in the remote process with write process memory. So we don't need to allocate read write memory, which is interesting. And I don't recall why this is the case. I would need to, look into that, but that sounds good. So we'll try that out. So next we need to call virtual alloc_x and call it on our newly created process using it, the handle that we have. And we are going to allocate it for the size of our shellcode. Okay, so let's just start doing this now. Another way that you can do this. So I showed the Control K thing where you can say, do this. I showed writing in comments, hey, do this. Another way you can do it is chat. So if I do Control L and I bring up a chat, you can see here where it says librs. This is the context. You can add files. If I wanted to add main or cargo or whatever, I can add more context, but it's automatically going to have all the context of the currently open file. So it can see all this. So let's say we've created a process in suspended state. Now we need to allocate memory in the suspended process using virtual alloc x. And it should, yeah, it says, I'll help you do that. And then it gives you the code. Okay. Okay, but it's not going to be perfect here because we can already tell there's a problem where it's allocating it for, and you know what? We are going to have one issue here. Okay. So it allocated it for 1024 bytes because it doesn't have the context here of the shellcode because the shellcode's in our main file and we have yet to pass it to the function. So we need to do that anyway because we're gonna eventually do that. So let's go ahead and do that, and then we can deal with this. So first, I'm gonna accept this. I'm gonna hit apply, and it's gonna modify our file to add this code. Now, this is also using memcommit and memreserve, but in the example, it looks like Bobby's only using memcommit. So we're going to try just using memcommit. And it also, yeah, that looks good. Page execute. Oh, no, it did read write. Okay, we don't want that either. So a couple things to change here. We're going to break it down to just memcommit, and then we're going to do, I believe, page execute read is what Bobby said we need here. Yeah, page execute read. Okay. And it knows there should be shellcode, but it doesn't have that context. So that's why it just gave us like a random size to try to use. But we're going to go ahead and fix that. So save this. We are going to update the wrapper function signature to take shellcode. It's going to be this array or vector. And so let's see if we say update this function signature to accept our shellcode as an argument. And you can see it already realized that, oh, well, if we're going to update this one, then we probably want to update inject also and add it there. Cool. That's fine. Let's do that. Boom, boom. Okay. Another thing we should probably do is, like, instead of doing this where it's always going to target Notepad, we should probably accept the process name as an argument too, so that we can target, you know, an arbitrary, or we can create an arbitrary process and not always create notepads. So we'll do that as well. And so now that I've updated that, though, let's go ahead and we'll update our call to it here. There we go. And you can see, like, I just clicked in here. It already knew that I needed to add that because we updated the function signature. And so I just had to tab complete, right? I didn't have to really do anything. So now that's all updated. And now we also want to pass, right, this as an argument instead of hard coding it here. So I'm going to ask, again, the large language model to do that. So instead of hard coding Notepad as the process to launch, let's move that to main and have wrapper and inject take the process name as an arg. We'll see how it does with this request. And it says, I'll help you. And we can see here some of the updates that it's making. So, and then it tells you I added process name to these function signatures, replaced hard-coded Notepad with a dynamic process name, and what is this? Added code to properly null terminate the process. Oh, right. Yeah. Okay. Okay. So let's accept all that. Always double check your code to, see what it's doing. So we see what it was doing, and we see the change here. That looks pretty good. So we can hit accept all or accept file. Used to be accept all. So now that should all be updated, but we have to change it in our call here. So let's say get the process name from the user. Okay. Let's get it as a command line argument. As a command line argument. Okay. And that's all updated. Now, we'll see here in a second if it works, but we need to now update our size. Boom. There we go. I don't think that should be a size T, but maybe. Let's see, virtual alloc X. Let's go look that up. Am I in the wrong crate? I am. How did I get? Oh, right. I was looking up memset earlier. Sorry. Okay, so if we go virtual alloc X and look at the function signature, it is supposed to be a size T. Okay, cool. So, and then if we look at that, we can see what that is. Base TSD. Okay, so we need to import that. That looks correct. Import, save, and we should be good. So now we have the shellcode length as our size, mem commit, page execute read, check if it fails. And last time, it knows that last time, even though it had a check for failure, I wanted to see something printed to console to confirm that it worked. So this time, it remembers that. And this time, it would have had, and not only added a check if it fails, it added a print statement to show me in the console that it worked, because it knows, like, I like to do that. So let's save this and run it and see if it works. It did not. Option on a none value. Okay, so something panicked at main 20. Oh, okay. I didn't put in a command line argument for the process that I want to target. So it had no process to target. So it failed right here. So the large language model did not account for what if the user doesn't provide a command line argument. So we're going to tell it to fix that. Okay, so I'm going to control L this to put it in chat. And I'm going to say add a check in case user forgets to provide process name as command line arg and exit gracefully with a help message. And there we go. Hit apply, accept, save, double check for errors. We could print the process name. I guess let's, why not? Let's see what it looks like. Okay. Now, hopefully it's also, formatting the process name correctly over here. It might not be, but let's just see what happens before we worry about that. Okay, so now you can see that it tells us, hey, you forgot a process name. Okay, so now if we add a process name, we'll say notepad.exe. Failed to create process, and this is what I was talking about. I don't think it is properly formatting that name like it was before. So if we look at panic.lib 40, it looks like, so if we go to 40, failed to create process, and we have that message here. Okay, so we're going to talk to the large language model about it again and say, okay, now that we are taking the process name as an argument on the command line from the user, I don't think you are properly formatting the process name to pass to create process A. Please address this. And we'll see if that's enough context for it to fix it. May or may not be, but we'll take a look here and see what it comes up with. Okay, so it's saying that command line with null. It's saying that if we format it in this way, that it's suggesting that it will search for the name of the executable, and it explains to you how it's going to search. I don't know about this. Let's see how I do it in, I think this one uses a sacrificial process. No, this targets a remote process. So let me think. One I did recently that targets a sacrificial process, I think debug hollow, or I mean debug inject RS. So let me take a look at how I did this before. Where is my... This might not be a good example either. Oh, no, that doesn't actually. Okay. Oh, I use NT create user process for that. Yeah, see, I'm formatting it differently. All right, well, anyway, let's see if this works, what it's suggesting. I'm a little concerned that it's not doing it the way that we started out, right? But we'll see. Also, I don't know why I added this. That seems unnecessary. Let's see what happens, and then we might have to go back and do this ourselves a little bit, but we'll see. Okay, so that did work. Its suggestion worked. You can see here the suspended process that it created. You can see our process name, handle, where it allocated memory. That all looks fine. Okay, I'm going to end task on that suspended notepad, and we can keep moving on. So you see how you have to understand what you're doing still, right? But it really, the large language model is generating all the code. So let's keep going. Go back to our example here. Next, we're going to use write process memory, and we're going to write the shellcode to the memory location, to the memory we just allocated in the target process. Let's make sure it put it in the target process. It did. Okay. All right. So I'm going to say write the shell code to the allocated memory. It already knows we're going to use write process memory because we imported it up here, right? So it can infer that that's the way that I want to do it in this case. So we'll hit tab complete on this. Just keep hitting tab complete. This is a check that it wants to do. If written equals 0, it probably wants to panic. There we go. I'm just hitting tab, like, right? I'm looking at the stuff. I don't want to do this yet. I'm looking at what it's showing me, checking to make sure that it makes sense, and then hitting tab. Okay, so we have an issue here. Let's see what it says. It says that it's expecting a raw pointer as a C-type C void, found a raw pointer, constant I8. So let's see. We have, it's using shellcode as PTR. Okay. Now, something also that you can do is you can ask the large language model to fix it. One thing that I do a lot in these situations, if I think it's going to be like a simple fix and the LLM can do it for me quickly, I'll just say, give me the compiler diagnostic, copy it, and then I will paste that to the large language model, letting it know that it made a mistake, needs to be adjusted, and then it will attempt to fix our code. In this case, it wants to cast this as the correct C type. We'll see if it's going to be allowed to cast it that way. Looks okay from a compiler error perspective. So now you can see again, it wrote a panic check, and then it also is going to write to console because it knows I like to do that now because I've been doing it each time. So let's save and we will run again and see what we get. And it all looks good. We see our process here suspended. We see, notepad, process handle, the location where the memory was allocated, and then the location where we wrote our shellcode to, which matches. So that's good. And we just have a couple steps left. So our next step is queue user APC. All right. So queue the shellcode to be executed. Okay. And that does not look right. This says, okay, function takes 3 arguments, but 2 were supplied. All right. So if we go look at the example, we see there are 3 arguments. The payload address that we should have gotten back from write process memory, the thread that we want to queue, and then something nulled out. Now, if we go look at queue user APC, did I spell it wrong? Oh, gosh, I got to close this tab. It's going to keep messing me up. All right. Queue user APC. Let's see what it's expecting. Okay. Yeah, that all looks right. Now, what are we doing? Remote buffer, which is what we got from here. That looks okay. Then we have our thread. Okay, so it's missing the value that's nulled out in our example, which is this parameter right here. Now, a fun thing you can also do is tell the large language model to look at the docs. So say you forgot a param on queue user APC. Here's the doc for reference. And we'll see what it says about that. Yes, looking at the docs, it requires another parameter. And it realized because I showed it the docs that this first parameter was probably incorrect in the way that it was set up. It has zeroed out the last one. That might need to be a null and not a 0, but we'll wait and see. So let's apply that. We'll accept that, Okay. And then there we go. And run and see what we get. Okay. It all looks good. Suspended process. Right. Okay. So that all looks good. You can see how easy this is, right? When you know what you're trying to do and you know how to use the large language model to get you there, it's easy and fast, right? So, okay, we have one step left, I believe, which is to resume our thread. And there it is. We're just going to resume the thread. Resume the thread. Another thing that I'm not showing here, but another useful thing that you can do, since it will take links and read references and code and everything, is you could also grab this link to this raw code and tell the large language model, if like say you're having a problem with this and you're like, man, it's not working. I don't know what I'm doing differently. You could say, hey, our program isn't working like the example. Could you please check the example and see what's the difference? And then link it to the actual code that we're working from, and it will do that. Okay, it's really good at it. Another crazy thing, I'll show you this in a second. Actually, let's see if this works. This should, I think we're done, and I think it should go ahead and pop calc for us at this point. And yeah, looks good. Let's fire it away. And boom, we got a calculator. And our process notepad is gone because it's been hollowed and replaced with calculator, as you can see here. All right. So at this point, it's done. We also have no errors, it looks like. So like it's done. We're ready to write a README, publish this, and we can start immediately calling it from other Rust projects as a imported library or crate as like a C2 module. It's done. Now, I know this took like 40 minutes. I went kind of slow for the sake of the video. I'm sorry the video is so long, but this is like really fast in right to be able to go, hey, I'd like to, write a module that does this thing just like Bobby did here. And how can I recreate this in Rust for my C2 module? Took me 40 minutes going slow and explaining what I'm doing, right? So this is how you should be using large language models to write malware, okay? Understand what you're doing, look at docs, and then tell the large language model what you need from it, all right? So pretty awesome. I'm like really happy with this. We will get rid of print statements now. We're going to clean this up for release. So let's say print ln, and we're going to find and replace with commenting it out. I'm just going to flip through. That one's already done, so we don't need to do that. I'm just going to remove that one. Find the next one. Yeah, we won't lose any functionality. Replace all. Done. Save. And now we're going to change this function, these function signatures to return a success message to our C2, which we'll also have the large language model do. Okay, so again, I'm just going to go in chat and say, it works. Great. Now let's update the wrapper and inject function signatures to return a success message as a string. So, and I'm even going to tell it that we're going to use it in a C2. And I'm telling you, it's not going to refuse. So when we call it as a module in our C2 implant. In C2, we get a message back letting us know if it worked. See, and it doesn't care. I even told it, here, hey, we made a process injection. I want a message back to my C2 knowing that it worked. And it's like, sure, doesn't care. Okay. So you can see it updating here to return a string. And you can see here where it's, returning that string. So I'm going to hit apply and accept all and boom. And then here we want to, I'm going to get rid of this print statement. And here I'm going to change this to collect the returned string message and then print to console. All right, I hit apply. I don't know, it wants to get rid of my comment. I don't care about that. It's going to clean that up and boom. And why do we have something on you? Oh yeah, I re-added that. Get rid of that. We don't need that. Okay, so now it should return only a message that is succeeded or not. Boom. Calculator spawned, successfully injected shellcode into process notepad.exe. That's what would be displayed in our C2 back to us upon success, right? Or if it fails, it would return one of these messages. Okay. So we're done. That's how it works. That's my workflow when I'm using Cursor for, writing malware and other red team tools. As I said, you can also use API calls to large language models if you don't want to use it as an extension in the IDE, but I highly recommend that you use it as an extension in the IDE. And I will go ahead and stop this video here. I'll do a separate video at some point to show you how to write your own API calls for large language models, which is based on the OpenAI API standard, which they all follow now pretty much. And I will publish this on GitHub so that you can use it as a crate, Rust crate in your own projects. And then usually about a month after I publish something like this, I'll go back, I'll make an OPSEC safe branch, and I will push a version that uses dynamic resolution of APIs and some other tricks. And I'll encrypt all the strings that are involved using LitCrypt and yada, yada, and make a much more OPSEC safe, evasive version for you to use. But this is a POC. And I'm going to push it like this as it is today for your learning, and really just so you could see my process of using large language models for writing malware. All right. So that was fun. Hope you enjoyed. And if you have questions, comments, hit me up. Peace.